Given that x, y, and z are real numbers that satisfy x equals the square root of y squared minus 1 over 16 plus the square root of z squared minus 1 over 36, y is equal to the square root of z squared minus 1 over 25 plus the square root of x squared minus 1 over 25, and z equals square root of x squared minus 1 over 36 plus square root of y squared minus 1 over 36. And that x plus y plus z equals m over n, square root of n, where m and n are positive integers and n is not divisible by the square root of any prime. Find m plus n. Okay, so let's first take a look at this system of equations, and it's not immediately obviously how we proceed. I mean, we have x equals square root of y squared minus 1 over 16 plus square root of z squared minus 1 over 16, and it doesn't seem like we can do anything nice with this. Like if we try to square it, we get like x squared is equal to y squared minus 16, 1 over 16, plus z squared minus 1 over 16, but then you'd have to add in this pesky 2 times the square root of y squared minus 16 times the square root of z squared minus 16. And like I just said, it's not immediately obvious how we proceed from this. You try using algebra, it's not easy. So instead, we look at all these square roots and we say, well, there's nothing nice algebraically we can do, but this difference of squares looks like Pythagorean theorem, like y squared minus 1/4 squared and z squared minus 1/4 squared. So let's try to put this into geometric perspective. X squared, no, just x is equal to square root of y squared minus 16 plus square root of z squared minus 1 over 16, excuse me. And what sort of thing does that tell us? It just tells us that x is the sum of these lengths. If you have a right triangle with hypotenuse y and one of the legs is 1/4. So let's say this is y and this leg is 1/4. Then this leg by Pythagorean theorem, if this is right, would be y squared minus 1/4 squared, which is y squared minus 1 over 16. And that plus this length, where if you have another right triangle with hypotenuse z and height 1/4, then your other leg is going to be square root of z squared minus 1 over 16, because 1/4 squared is 1 over 16. What does that tell us about x? It just sort of tells you that if you take this triangle, and sort of smush them together, the third side is going to be length x. So I can sort of draw it like this. If this side length is y and this side length is z, this side length is x, and maybe I should draw this a bit better. If this is y and this is z, and this side length, which is the sum of these two segments, is going to have length x because of this first equality. And we have to remember that to include the fact that this length is 1/4, where this is the altitude. Okay, so that's useful, but what's that going to tell us about the other two equations? Well, we can sort of do something similar with this. Like we have that y is equal to the square root of z squared minus 1 over 25 plus the square root of x squared minus 1 over 25. And that makes us think about more right triangles. In particular, if you have right triangle with hypotenuse z and leg length 1 over 5, then this third leg is going to be square root of z squared minus 1 over 25. And we can sort of put this together with another triangle with side length with hypotenuse x and height 1/5. If this length is x, then this length is square root of x squared minus 1 over 25. And thus, this length over here, which is the sum of those two, is just y by the second equality we're given. So you have this triangle with side lengths y, x, and z, where the height to length y is 1 over 5. But wait a minute, these two triangles are actually congruent to each other by SSS congruence. They have the same 3 sides. So what does that mean? It just sort of means that the height from this segment to y is equal to 1/5 as well. And maybe I should color code this to make it easier to see. Or if you have sort of this height to y, it's going to have length 1 over 5. And this height over here, which I'm going to do in green, this height to x is 1 over 4. 1 over 4. That's useful. But let's talk about z. And this third equality, z is equal to square root of x squared minus 1 over 36 plus square root of y squared minus 1 over 36. And what does that tell us? Well, it tells us that if you sort of have two right triangles and one of them has hypotenuse x and height 1 over 6, then you have this is x, this is 1 over 6, and this leg length is square root of x squared minus 1 over 36. And if you have another triangle, right triangle with side length y and leg 1 over 6, if this is a right angle, then your second leg, excuse me, is y squared minus 1 over 36, because 1/6 squared is 1 over 36. So if you sort of put these two triangles together, you get a triangle with side lengths x, y, and the third side would be z with height 1 over 6. That's also congruent to this triangle over here, which means that if you drop the altitude to side length z, and these 3 altitudes are going to intersect at the orthocenter of the triangle, they're going to intersect at a single point, this height over here is going to have length 1 over 6. So how exactly does that help us figure out what x, y, and z are? Well, let's think about it. We have the 3 bases of this triangle, x, y, and z. We have the 3 heights, which are 1/4, 1/5, and 1/6. And that makes us think about areas, because the area is half times base times height. And in particular, what do we get? We get half times base x times the height to x, which is 1/4, is equal to half times the base y times the height to y, which is 1/5, which is equal to half times the base z times the height to z, which is 1 over 6. All of these are equal to each other, which means that if we multiply everything by 2, we just get 1/4 x equals 1/5 y is equal to 1/6 z. And how does that help us? Well, what happens if we get y and z in terms of x? and substitute them into this first equation, then we just get an equation in terms of x, which we can use to solve for x. So how do we put y and z in terms of x? Well, we can multiply both sides of this equality by 5 to get 5 over 4x is equal to y. And we can do the same with this equality, except we multiply both sides by 6 to get 6 over 4, x is equal to z. I'm not going to simplify this right now, and we'll see why. So we plug y and z into this first equality, and we get x is equal to square root of y squared. Well, y squared is 5 over 4x squared, which is 25x squared over 16, minus 1 over 16, plus, well, z squared is 6 over 4x squared, so that's equal to 36x squared over 16, minus 1 over 16. And now we have our one variable equation in terms of x, which we can now solve. To start off, we multiply both sides by 4 to get 4x is equal to 4 times this thing. And what this 4 does is it distributes to each of these and removes the 16 from the denominator. So if you can sort of imagine getting rid of this 16 and this 16, this 16 and this 16, what we've done is we multiply this right-hand side by 4. We have 4x is equal to 25x squared minus 1 plus 36x squared minus 1, all square rooted. And we sort of want to simplify this. So what we do is we move this to the left-hand side by subtracting both sides by it. We have 4x minus the square root of 25x squared minus 1 is equal to the square root of 36x squared minus 1. And we square both sides because now the squaring isn't going to be nearly as messy. We get 4x squared, that's 16x squared, plus this thing squared, that's going to be 25x squared minus 1. And then we have to add in the 2 times this times that. And we get minus 8x square root of 25x squared minus 1 is equal to, when we square the right-hand side, we get 36x squared minus 1. And we can add 1 to both sides to get rid of this minus 1. And we can sort of combine like terms to put all the x squares on one side. So we subtract 36x squared from both sides and add 8x squared, 25x squared minus 1 to both sides. We get 16x squared plus 25x squared minus 36x squared is equal to 8x squared of 25x squared minus 1. And we can divide both sides by x to get rid of one x term. And when we combine like terms, 16x plus 25x minus 36x is equal to 5x. So we get 5x is equal to 8 times root 25x squared minus 1. And once again, we square both sides to get rid of the square root. We get 25x squared is equal to 64 times 25x squared minus 1, which is equal to 64 times 25 is 1600 x squared minus 64. And thus combining like terms again, we got 64 is equal to x squared times 1575, which we can factor out as 25 times 63. And what do we get for x? Well, we get, if we square root both sides, we get 8 is equal to the square root of this right-hand side, which is x times 5 times the square root of 63, which is 3 root 7. So x is equal to 8 over 15 root 7. And now for our last step, we have 5 over 4x equals to y, 6 over 4x is equal to z, and we want to find x plus y plus z. And x plus y plus z is going to be equal to x plus 5 over 4x plus 6 over 4x equals to 15 over 4x, which is what we want to find. So we just need to find 15 over 4x, which means we just multiply this thing by 15 over 4. And we get x plus y plus z is 15 over 4 times x, which is equal to 15 over 4 times 8 over 15 root 7, which is equal to 2 over root 7. And that's all we needed. We're done. Our answer is the sum of m and root m, so it's 2 plus 7, which is equal to 9. So that's our final answer. And that's it for this video. Thanks for watching, and I will see you next time.